Hello and welcome. In this video, we're going to be looking at equations with rational exponents. So basically, we're going to be taking the concept from the previous video and looking at how we solve equations when those exponents are present. So in this first example, we're going to start off with something relatively simple. Um, Basically, we have x to the power of 4/3 equal to 16. And we need to find the x, which basically means we need to get the x by itself without the exponent. And so the easiest way to do this is to think of how you would cancel out a fraction if it was in front of an x. So if I want to get rid of a fraction 4/3, then generally what I would do is multiply by the reciprocal. And so to multiply by a reciprocal, that basically just means the opposite of that fraction, or a fraction with the same values, but the numerator and denominator are flipped. So if I had a fraction that was, say, a over b, then to cancel it out, I would multiply by the opposite fraction, and it would just come out to a 1. So when I'm looking at this first example, if my exponent is 4/3, then to cancel it out, I'm going to multiply it by 3/4. And so the only other bit of information that we need to remember is that anything I do to one side, I need to also do to the other. So if I'm going to multiply 4/3 by 3/4 on the left, I also need to put an exponent of 3/4 on the right. So to show that a bit more clearly, we said we want the exponent to cancel out by multiplying with 3/4. Since there is no exponent on the 16, or it's technically like a 1, I can just put the 3/4 power over here. That will then cancel these. So to figure out the value of x, we just need to figure out 16 to the 3/4 power. So from our last video, we said that you look at it as a two-part process. The 3 represents raising to a power, and the 4 in the denominator of the fraction represents a root. So I want to take the 4th root of 16 and then raise that to the 3rd power. And technically I could do that the other way around. I could do 16 cubed first. But as I mentioned in the previous video, I just like to work with the smaller numbers. So to me, it's faster to do the root first and then the exponent. So the 4th root of 16 would become 2. And then 2 to the power of 3 would become 8. So if I'm simplifying my equation down, the left side would just become x because the exponent's canceled, and the 16 to the 3/4 would become 8. So that would be my answer for the first question. So notice for number 2, we have a very similar looking problem. The biggest difference here is that we have this 4 as our coefficient. So the basic idea for all of these is that we're going to deal with the exponent last. So we need to deal with all of the extra terms just like we would when we're solving a standard, simple equation. So if I want to get rid of that first 4, I just need to divide 4 on both sides. So it's going to cancel this 4 to give me just the x to the 3/4 power. And then 108 divided by 4 gives me 27. So now we have something that looks like the last question. All right, so once again, we want to get rid of the exponent. So if I'm starting with a power of 3/4, I want to get rid of it with an exponent of 4/3. And if I'm going to put an exponent of 4/3 on one side of the equation, I need to do that also to the other. So these guys will go away, which will just give me an x on the left. To figure out 27 to the 4/3 power, I want the third root of 27 raised to the power of 4. Of course, the third root of 27 is 3. And 3 to the power of 4 is 81. So with this next one, there's a couple of things that we want to notice. The first is that we need to get rid of the 6 on the end first, just like in the last problem where we had to eliminate the coefficient of the x. The biggest difference here, though, is that the parentheses include both the 3 and the x. So if we're thinking of the order that we need to do our steps, we're going to get rid of the +6 first, because that's just on the end. Then we're going to need to do the exponent, and then we're going to worry about the 3, because again, we deal with whatever's in the parentheses last. So we'll start by subtracting 6 on both sides. So that'll give us 3x to the 1/2 power equal to -6. And so normally we would use an exponent to get rid of that fractional power. But I remember that 1/2 is basically the same as taking a square root. So it could look something like this. I also remember that square roots cannot result in negative numbers. So this actually will give us no solution. Because again, the square root of a negative number would produce an imaginary value. So keep in mind that you can only put no solution when the denominator of your fraction is even, or in other words, when you're taking an even root, and that would have to give you a negative value. So again, even root equal to a negative number, we know we have an imaginary answer, which means we get no solution. Now this one looks a little bit more complicated, but again, we're just going to follow the steps one at a time. So we need to get rid of everything outside the parentheses first, then we'll deal with the exponent, and then we'll deal with whatever's inside the parentheses. So we definitely want to start by subtracting 1 on both sides. And then dividing by the -3 to get rid of that value in front of the parentheses. So now when we go to do our exponent, it's across from a positive number. So basically the imaginary solution issue that we ran into the previous example is not really going to affect us here. So we're going to put an exponent of 2/3 on both sides, which will get rid of this. And then we will simplify the 8 on the right-hand side. So we want the cubed root of 8 raised to the second power. Cube root of 8 is 2. And 2 squared equals 4. So that brings us down to 2x minus 1 equals 4, which we can then solve using our normal steps. So our final answer here is that x equals 5/2. So let's do one more just to kind of drive it home. So once again, we'll start by subtracting the 11 on both sides. So we get x to the 2/3 over here, 16 over here. So we need an exponent of 3/2 on both sides, which means we need the square root of 16 raised to the third power. So we know the square root of 16 is 4, and 4 to the power of 3 is 64. So our final answer over here would be x equal to 64. That's all I have for this one. I will see you guys next time.